All right, so my name's Isaac Gear. This is Tommy Autio, Dante Stillo, Jackson Steele, and James Loy. We're Siligram, and we're working with Texas Instruments to solve a problem with their single wafer etching system. So the problem is difficult to detect visually. So what the process line is like is there's an underbump metallization deposited on the wafer, and this just provides a way for the copper to stick onto the wafer itself. And then there's a photoresist pattern deposited, and then copper, nickel, and palladium to form the vias on the wafer. And then that photoresist is stripped, and in between there, right after that, you need to remove that underbump metallization, which is coating the whole wafer. And so in that process, when they strip that UBM off, sometimes with a single wafer etch system, they cause some undercut right there, which provides a weak structure for the via. So under operating current, sometimes that via can peel off. So the goal is to have a via that looks like this, where it's almost vertical straight lines. So to detect this issue, it's difficult to see it visually, as I said before. So we need to detect it with a weight measurement tool down to 1 milligram accuracy, and that'll give us the accuracy we need to detect whether it's a pass or fail wafer. So Dante is going to go over what tool we're going to use to.
Perfect. Thank you. So like Isaac said, the only way to detect this defect is by measuring the weight. So in order to do that, we looked through a lot of different options and did a lot of research. The method that we chose is the weigh cell, on the bottom left, using electromagnetic force restoration technology. And you can see in the diagram on the bottom of the right-hand column, the way this works is by basically placing the wafer on top of a platform that's attached to a solenoid. That solenoid then uses a control system to actuate and levitate to make sure that it maintains the same level. The voltage and current measurements that are necessary to do that are then fed into a microcontroller, which will be mapped to a database to then link that voltage and current into a weight measurement. We're both looking at, and we've already started prototyping our own design this semester with a solenoid and using a 3D printed chuck. But we're also looking at off-the-shelf solutions as well to see if that would maybe be a viable solution. Because this problem would help with all of their single batch etching systems throughout like the entire world. We want to make sure that this is a reproducible result for them so that they can hopefully implement it everywhere. Some future milestones that we're looking at are integrating it into Texas Instruments' manufacturing process line, which will then allow a robotic arm with an end effector to drop it off to our system, allow it to get a weight, and then basically take it off and then continue the line.
Do you have to calibrate this device?
Yes, and that's something that we didn't hit on. But we need to we'll need to place known weight values on it, and then make sure that whenever we do the database mapping, that it kind of fits hopefully a linear line. And then also they'll have their own manufacturing standards within their their factory. So it'll probably be a repeatable thing that'll happen every weekly or monthly basis.
What causes an over-etched wafer?
So the process that you have to remove copper off of a wafer, you have to use a wet etch system, so it's a chemical bath. And so that chemical removes the UBM, but it also comes under the via and removes some of the copper from the via that you want.
Yeah, the entire wafer gets like lowered down into this chemical,
Okay.
which then kind of makes this happen.
Okay.
So is the weight a pretty good indicator of over-etching?
Yes.
Yeah.
Yeah, and because there's additional layers on top, you can't see it visually, so you have to do that.
Yeah, determine that.
Is that the only way
Yeah, that's what I believe so.
currently?
Yeah. Or X-ray technology, but that's really difficult to implement for every wafer on their manufacturing line.
What's done right now to detect that?
Weight measurements.
I mean, so they've already got a weight measurement system in
They
place.
do, but they have a accuracy of 0.01 grams, and that is not sufficient enough to detect with at least 95 to 99% accuracy that these wafers have gone through over-etching.
Okay, you found something in the market that has that sensitivity.
Right,
We're
we have
prototyping
that.
our own and then looking for off-the-shelf solutions as well. And hopefully that weigh cell that uses that EMFR technology will be able to get down to that sensitivity.
isn't there gonna be a range for good, I mean, for the good wafer versus the rejected, to be rejected wafers or the corrected wafers? Isn't there a range actually rather than a single wafer?
It's on the.
Yeah, so it's this
Yeah.
middle,
Okay.
Are you guys gonna be
Very good
testing
slide.
with
It's a
real?
very good slide. indeed.
real wafers, yeah,
Yes.
correct. We will be, we
Mhm.
do have some wafers that we're gonna be testing actual.
Nice slide, guys.